Hi friends, welcome to Jitesh classes. Today we are starting a new chapter, that is current electricity. This is part 1, and in if you didn't saw the last lesson, that is fluid statics, which I explained, the links are in the description. Go and watch those if you want. And this now current electricity. Current electricity, now I will start with the basic concept, that is electric charge. Electric charge is denoted by Q, and electric charge is the physical property. Electric charge is the physical property which when kept in a which will experience a force when kept in a electric field or electromagnetic field. And I'll say only the formula that is only important for us in this chapter. See, Q is equals to Ne is the formula. Q is equals to Ne, and N is the number of electrons or protons. We can say mostly electrons. And E is the charge of one electron or proton. Charge of electron. That is equals to 1.6 into 10 to the power of minus 19. Kunsa something. And the unit, SI unit is coulomb. 1 coulomb. SI unit is the SI unit for this electric charge is 1 coulomb. And it's a scalar quantity. Okay, that's about electric charge. Just simple, that's it. And next, now electric current. I love this part. Electric current is denoted by I. In our minds we will think that electric current, what is current? The basic thing of current, we will think that, see, basically we will think just if we switch on a light or fan, something, an electrical instrument or conductor, how it flows electric current, what we will think that if we switch on, the electrons will travel from the wire through the wire to the bulb, and the lower potential, those all will vary, and that will conduct electricity, and the light will glow. We will think like that, but that's not the thing. Electric current is the rate of flow of charge. It means that there is charge in that. If in a conductor, see, I will explain in detail. First I will write the definition. The rate of flow of charge per unit time, or flow of rate of flow of charged particles, the rate of flow of charged particles. See, the charge, it means that they are charged. Electrons or something which are carrying the electric current are charged. So we will say that we can also say that is rate of flow of charge. See, per unit time. Okay, per unit time. Now see, because see, rate of flow of charge means, I'll explain. We'll take a conductor. If we take a conductor or a bulb, if we need to glow that bulb, we'll connect it to a battery, or we'll connect it to a switch or plug, and we'll connect it to the electric current. How it will come? See, the battery or something, it will generate energy. It will pass the energy. It will generate the energy. It will generate the energy to push the charge. To push the charge. See, the battery or something will push will make the charge flow, the energy. See, that battery will conduct, battery will release some energy or send some energy, and that energy will push the charge. Due to the when it pushes, see, when the charge will push, say when the energy will push the charge flows. Due to the flow of charge, electric current conducts. That's the correct thing. Means the electric field containing energy. See, the electric field, from if we switch on or something will happen to conduct or to glow a light or something, or fan, what will happen? We'll switch on or we'll connect to a battery. Then the charge in it will be pushed by the energy supplied by the battery. By the energy, it will be pushed. It will flow. The current will flow. Due to that, the electric current will come. Understood? That's it. That's the thing. Means the energy will push due to the flow of electric charge. The flow of electric charge, the electric field creates. Due to that, the bulb will glow, and the electric current will come. That's it. Means electric current will generate due to the due to the flow of charge. That is electric field. That's the correct. That's the correct thing. What will happen in a conductor? Okay. Now, let us. I'll say the formula for that. See, I is equals to Q delta Q by delta T is the charge. Delta Q by delta T is the I, means net flow of the charge by net flow of the time is the electric current I. And now electric current, SI unit of electric current is 1 coulomb per 1 second is SI unit. So 1 coulomb per 1 second is 1 ampere. See, the ampere, A denoted by A is the SI unit of current, electric current, and electric current have both magnitude and direction. I'll explain later now after this, but it's a scalar quantity. But it's a scalar quantity. It does not follow vector law of addition. Vector law of addition. It adds up like a scalar quantity. Okay, and now when the net flow of charge is not steady, means it is flowing. Wait, I'll see. When the net flow of charge is not steady, then the expression or equation or the formula will be I is equals to del dq by dt. dq by dt. It's an important formula. I is equals to dq by dt. When dt is a very small interval, by the word derivative, by the d we can understand that it's a very small small interval of time, and at that time the flow of charge and when the charges charges varying, that how much change it per that time, how much change the time, interval time, that is instantaneous. This is instantaneous electric current. Instantaneous electric current. Instantaneous electric current. Okay, and between we can say also that delta t tends to 0, limit delta t tends to 0, delta q by delta t is dq by dt. And see, when it is in a normal interval like t is equals to 9, between an interval of time, see this is at an instant, like at a particular time, what is the current, if we ask how much is the flow, that is that instantaneous. But here average current is delta q by delta t per a normal interval of time, small huge interval, that's from t 2 seconds to 1 second, like that. It is average electric current, average. Okay, a problem on this, I'll say a problem, numerical problem on this. See, the charge q, the charge of electric current, or the charge is given, or the charge of electric current, or the charge is given as q is equals to 5t square minus 2t. 5t square minus 2t. What is the instantaneous velocity? Instantaneous current. Find I instantaneous at t is equals to 1 second or something. T is equals to 1 second. T is equals to 1 second, and I average from t is equals to 1 second to t is equals to 3 seconds. Fine. Okay. Now, answer, solution. First, we know the formula for the instantaneous is dq by dt. Then I is equals to d of the means dq by dt, we will substitute here dq. Q is this 5t square minus 2t. 5t square minus 2t by dt is the electric current now. So I instantaneous means it's I instantaneous, I write here instantaneous. See, I instantaneous d in, see, we know that derivative means that only n x power n minus 1, 2 into 5t minus 2, 1 into 2 into t power 1 minus 1, t power 0 is 1. So I is equals to 10t minus 2 is the I instantaneous. See, for at 1 second now. At t, I will do that. We got this now. I is equals to dq by dt delta q by delta t. So I is equals to 10t minus 2. So at t is equals to 1 second, the instantaneous he asked. So I at 1 second is 10t. How much? 10 into 1. 10 into 1 is 10 minus 2 is 8. I is 8. And average now. I is equals to delta q, means q at this, q is 3 seconds. So q at 3 seconds, or we can take q is also 2 seconds. Okay, I'll take 2 seconds. Q is 2 seconds. Sorry, q at 2 seconds minus q at 1 second, means delta q, no, the change in the charge, and here 2 minus 1, and this is q at 2 seconds, q at 2 seconds, how much? Q at 2 seconds. Here q at 2 seconds is q into q is equals to at 2 seconds. So 5 into 2 square minus 4 into, see, for instantaneous means we are using that formula dq by dt, because we need at a particular instant. That one for average means at that point, means q at, by using that equation we will find, see, q 4 into 2, sorry, 2 into 2, 5 into t square, 5 into 2 into 2 square minus 2 into 2, that is q 2 at 2 seconds is equals to q at 2 seconds is equals to 2 square 4, 20 minus 4 is 16, and q at 1 second, how much? Q at 1 second is 5t square minus 2t, 5 into 1 into minus 2 into 1 is 3. How much? 5 into 1, 2 into 1, that's 5 minus 2 is 3. Directly 3 we got as 3 coulombs. This is 3 coulombs, that is 16 coulombs, and here 16 coulombs minus 3 coulombs. 16 coulombs minus 3 coulombs is the average current. I is equals to 13C. I is equals to 13C. That is the average. If we take equivalent like 4 seconds and 2 seconds also, we will get like that. And now, direction of the current. Direction of the current, almost it will be, see, direction of the current will be always perpendicular to the cross sectional area of the conductor. Cross sectional area means it is if it is drawn in this direction. See, if it is drawn in this direction, direction of current now, direction of current. What's okay, no denotation. See, if it is a conductor, it's a conductor, it's a conductor. If it's a conductor, in that this is a cross-sectional area. This is a cross-sectional area. In that, see, the current will flow perpendicular to the cross-sectional area. This is cross-sectional area, and perpendicular to the cross-sectional area is flowing. And other words we can say that, see, current. Okay, first I write perpendicular to cross-sectional area. Cross-sectional area. And we clearly complete. And this one, see, the current will be in the direction of positive charge, not to the positive terminal. It's the positive terminal and negative terminal. It will not be to the, every time it won't be to the positive terminal. It's the flow of positive charge. The flow of electric current is in the flow of positive charge or flow of positive charge, or opposite, flow of positive charge or flow opposite to the direction of, opposite to the direction of electrons. See, if the electrons are moving in this direction, then what happens? The electric current flows in this direction, I. Electric current flows in this direction. If I is in that direction, electric current is in this direction. That's because, see, if this is same, see, that's because how that will go, I'll say, see, this is a conductor, metal conductor. In that positive ions are there, positive ions, all positive ions. When it will become positive ions? When they release an electron. When they lose an electron, there will be the ions, positive ions. So those ions, the electrons are revolving. See, electrons nature is to random motion. See, here this is positive and negative. If we take, see, positive and negative. The electrons are negative charge. See, electrons attract to the positive charge, attract to this side, attract, many electrons attract, completely come this side. When they come to this side, when they come to this side like that, then see, they are coming here, they are attracting towards this side. Then what happens? The free path for the electricity to conduct, to see, charge, to make the charge flow, they need the free space, so that when these are attracting this side towards this, in this left direction, okay, something, see, towards, when they are attracting to this side, then in this direction, then what? To the positive direction, then the electrons, then the electric field will move towards that. See, the electrons are getting vacant, those shells, the electrons are coming this side, the space, there is free space, and that electric current is going in that direction. So every time the electric current is opposite to the direction of electrons. See, once again I recall that the electrons are in here, the positive ions left one electron, and these electrons are attracting towards the positive side. When they are attracting, the electric current, or that is electric current is rate of flow of charge. The charge should flow in this in the free space, they need some free space. Due to that, they are moving in this direction. How much? See, but this is, if when this comes, when this attracts here, it will be vacant. It is going, and this attracts. Like that, the electric current flows. That's why it is opposite to the direction of the electrons. That's the direction of electrons. That's the direction of electric current. And now, see, charge does not accumulate. Charge does not accumulate. Charge does not accumulate. Does not accumulate. It is conserved, neither be created nor be destroyed. It is, or electric current or charge. It is conserved. It is conserved. That is when electric current. See, conductor. This is a conductor, and this is this side. How much charge? See, in that we will take a cross-sectional area. How much charge is entering from this side? The same charge is going from this side. How much is entering from this side? The same charge will be went from that side. Will be, see, delta Q is delta Q. How much is entering delta Q? The same delta Q is going outside. The charge is conserved, neither be created nor be destroyed, but it is not accumulated, means it is not gathered inside, it is not stored, it is not increased, it is conserved. It is, means it is, how much is coming, how much it will go, conserved. Charge is conserved. This is the main point, and one of the main point. And see, this is one thing. Electric current in UCM. Electric current in UCM. In UCM means in circular motion. See, this is the nucleus, and this inside, this is a nucleus and thing, and here there is an electron, one electron, and here the electric flow, it is moving in this direction. The electricity is flowing in this direction, and we can say that equivalent current, because it is moving with the same radius, with the same speed. So we can say that is an electric, means same charge, equivalent current in this. R, radius is R. Okay, equivalent current. How? Here I is equals to, what's I? I is equals to E. We know that Q by T. Here T, what is T? T is 2 pi R by V, because 2 pi R, we know circular motion, 2 pi R is the distance, and by the velocity is time. So, and N is 1, because 1 electron. So E, we no need the charge, that is now just they are asking, we need the formula. So E by 2 pi R by V, this V will come outside. So EV by 2 pi R is the current, equivalent current here, electric charge in UCM. This is electric current in UCM. I is equals to EV by 2 pi R. If number of electrons are there, QV by 2 pi R. And next one, almost all are covered in this. See, and one thing is there, that's here, charge carriers. Charge carriers in solids. What happens? In solids, the electrons, positively and negatively charged electrons, are the conductors, are the charge carriers. are the charge carriers, current carriers, sorry, a small mistake. They are the charge, means they are the electrons. In solid conductors, electrons contains, if their electrons are charged, see, electrons are the charged particles in that, and the electrons will conduct the electricity. If they will flow, the electricity will, see, when the electrons flow, when the charge flow, current will generate. When the current will generate, the current will form, see. So that the charge electrons are the charge carrier, current carriers. Here in solids, liquids in electrolytes, see, in electrolytes, NaCl, Na plus and Cl minus, they are free, and they will be, due to the electrolytes, they will conduct electricity because they are free, they will give free ions the space to go. So in liquids, positively and negatively charged ions, positive ions and negative ions. And in gases mostly all are insulators, but highly ionized, like in X-rays. Ionized means particles which are at high pressure and high temperature, those will be ionized. Those are the in those cases, those will be the gases and conductors and gases. And at last, it's a lesson, semiconductors. In that, electrons and holes. This is a chapter, we will cover it at that time. See, one important thing in electric current is the battery or the switch or something, the electric current, what it will do, the energy, see, the voltage will push the charge. If it will push the charge will generate electricity. If how much it means, see, the energy will push the charge, the battery or switch, they'll generate energy that will push the charge, that is electric field. And how much energy, how much the charge is flowing, how much it pushes, that much the speed will be. How much speed will be, the electric current will be that much fast. That means the electric current will be that much more, like that. That's if one that's in amperes, like that. Means it will be per 1 second 1 coulomb, means it is ampere, like I said, no, that one. And this is current electricity part 1. The session was completed. If you like my explanation, don't forget to like, share and subscribe to my channel.